Hello students, last class we are seeing the same Joule's law of heating. Today we will continue that. See H equal to I square RT Joule's law of heating as already told. So water H means the heat energy produced in the resistor of an electric circuit is directly proportional to the electric current flowing through the circuit and directly proportional to the resistance of a resistor, and it is directly proportional to the time for which current flows. It is directly proportional to the time for which current flows in the circuit. The current should flow in the circuit. Okay, so these are the things you have to remember. Okay, so this is called Joule's law of heating. Okay, and this will be asked for 2 or 3 marks. So remember this, write down this properly. I hope this is clear. So very easy it is. Okay, Joule's law of heating. Joule is a scientist who worked more on heating energy. Okay, that is why you call energy. SI unit is Joule. SI unit of energy is Joule. Okay, H equal to I square RT. I means what? Electric current. So H, see the heat energy produced in resistor of an electric circuit is the heat energy produced in the resistor of an electric circuit is. Okay, this is the heat energy produced in resistor of an electric circuit. So I means I square means what it is? It is the electric current flowing through the circuit, and R is resistance of a resistor. T is the time through which the current flows in the circuit. So they are directly proportional. All are directly proportional. Directly proportional to the square of the electric current flowing through the circuit. Directly proportional to the resistance of a resistor. Okay. Third one, time. Directly proportional to the time for which current flows in the circuit. So these are the very important point. Please note down this and please do complete perfection with these 3 points. I hope this is clear. So next we will move to the practical applications of heating effect of electric current. Note down this. Pause the video. I think you have noted down this in the last class. If you have still not noted down, so please note down this. So we will move to the practical applications of heating effect of electric current. We will move to the practical applications of heating effect of electric current. So practical applications of heating effect of practical applications of heating effect of electric current. Practical applications of heating effect of electric current. See, what are the practical applications of heating effect of electric current? See, first one, you remember heating effect of electric current, the heat is inevitable. We cannot, what we can say, control that heat. So, in sometimes all the heat energy will be converted into, so all the electrical energy will be converted into heat energy. Sometimes some of the electrical energy will be converted into heat energy. But however, heating is inevitable. It cannot be changed. There must be little bit heating at least. So what are the practical applications of heating effect of electric current? As we know, there are a lot of practical applications. We have seen electric iron. So electric oven are there. Then electric heater coils are there. Then bulb is there. Okay. Then what we can say? Fuse. These are the examples of practical applications of heating effect of electric current, or where heating effect of electric current is used. So these you have to remember. You have to remember these points where the heating effect of electric current is used. You must remember all these formulas. Here the very much important thing you have to remember, where the practical applications of heating effect of electric current is used. Okay. So in this, very much importantly, we are going to see these two concepts, bulb and fuse, for your syllabus. So how heating effect of electric current is used in bulb and fuse. Okay. I hope you have all known about this bulb. So bulb will be there. Okay. Like this or not, no need to draw the bulb. So you have seen the bulb, I hope. So in what happens bulb, there is a, okay, let me tell you. In what happens bulb, there is a tungsten material. Okay, there is a tungsten wire in the bulb. So all the heat energy that goes to bulb will be absorbed by that wire, and after certain time that heat energy will start emitting the light. So most of the heat energy gets converted into light energy. But see here, the lot of heat energy is coming, so the tungsten material should have high melting point. If low melting point is there, means as the temperature increases, as more heat energy comes, the temperature increases and the material will melt. That is why tungsten material is used, which is having highest melting point of around about 3380 degrees Celsius. You have to remember this. In bulb, tungsten material is used. Okay. So electric bulb. So bulb means the bulb, old bulbs I am telling, not about these LED bulbs. LED bulbs are using different concepts. Whatever the bulb we are discussing here, these are the old bulbs. 60 watt bulbs, 100 watt bulbs you have seen. So those bulbs I am speaking about. Okay, not about these LED bulbs or tube lights. They use different concepts or different things. So in those bulbs, what is there? Tungsten material is there. This question will be asked, why tungsten material is used in the bulb? Tungsten material, why it is used? Because it is having high melting point. For the application of the heating effect, as the heat generated, their temperature increases and light emits. But to light to glow, the temperature must be more. So if the other materials are used which is having low melting points, then they will melt and then there will be no light at all. But here what happens, tungsten is having high melting point of around about 3380 degrees Celsius. That means even though lot of temperature increases, lot of heat energy produces, so still it will not melt. So that is why tungsten is used in the bulbs. Okay, in the filament of bulbs. The filament of the bulbs is made up of tungsten material. Okay, so this is very much important. The tungsten is used in the making filament of bulbs because it has high melting point. So that is enough. It has high melting point, so that maximum temperature can be produced in, maximum heat can be produced with the heating effect of electric current. So as the heat increases, what happens? It is tungsten is having high resistance also. High resistance means lot of heat is produced. As the resistance increases, heat energy increases. That means resistance increases means heat energy increases means what? Lot of heat is produced. If the lot of heat is produced means what? Lot of light will come. Okay, light will glow for long time. So light will glow for long time. As the resistor is more, heat energy is more. Heat energy more means lot of light will come to long time. Okay, the emitting of light will be there for long time. This is how bulb works. You should remember. And in bulb, there are two gases filled, nitrogen and argon. You should remember these two. Why these two gases are filled in bulbs? Because if it is not filled, if these two gases are not filled, what happens? In bulb, oxygen may enter. If oxygen enters, then tungsten will react with oxygen and it will become tungsten oxide. Then it will not conduct properly. So that is why nitrogen and argon are filled in the bulb. These two are non-reactive. These two are non-reactive. Mainly argon is filled. Why argon is preferably filled? Because it is a noble gas. Argon, krypton, xenon, radon, neon, these all are noble gases. These will not react with any material easily. So these two materials will not react with tungsten. Hence, tungsten will not convert to tungsten oxide. Tungsten will remain as tungsten and it produces heat energy, it produces light energy. If nitrogen and argon are not filled, means oxygen enters in the bulb and it remains, the tungsten material reacts with oxygen, becomes tungsten oxide. So it will not conduct electric current properly. Okay, so that is why nitrogen and argon are filled in the electrical circuit. So another one is there that we call it as fuse. So okay, fuse. What is fuse? I hope this up to this much you are clear. So what is fuse then? Fuse is a material that is used in electrical circuit which melts itself when there is overloading or short circuit of the electric current. See, when there is overloading or short circuit, then it melts itself. Okay, material used in electric circuit. Fuse is a material used in electric circuit that prevents electric circuits that prevents the short circuit or overloading of the circuit. Short circuit or overloading that prevents the circuit from short circuit or overloading The material used in electric circuit, fuse is the material used in electric circuit that prevents the circuit from short circuit or overloading. Okay. Material used in electric circuit that prevent the circuit from short circuit and overloading. So fuse is the material. See, suppose what happens if I connect the fuse here. If there is a overloading, okay, plus minus, let me say. So okay, resistors are there. Okay. See what happens here. I will take one resistor. Fuse will be connected here. Okay. In series always. Let me say this is fuse. So what happens is when there is a overloading or short circuit means what? Resistance becomes zero. Complete flow of current will take place. It is just like your pipe is, if there is water is flowing in the pipe breaks, water comes out. Similarly here there is lot of current flowing in the circuit. Okay, then short circuit means that current will come out and burning will start. You have seen the buildings and you have seen some shops gets burned out due to short circuit. Okay, short circuit means what? The resistance will become zero When the resistance becomes 0 means current will flow high. The current flows high means it comes out of the thickness of the wire. Then burning of other things will takes place. What other things present there? So here the fuse is placed. Fuse is already been in the material. See what happens if there is lot of current is flowing, or let me say I can place fuse here also. Okay, if lot of current is flowing, what it does, fuse, it starts melting. Okay, when it melts, it comes here and there is no flow of current. It melts means it vanishes. When it vanishes, the circuit breaks, isn't it? This part will break, then the current will not flow through these resistors. If I say these as R1, R2, R3. When the fuse breaks, the current will not flow through R1, R2 and R3. Hence, there will not be any short circuit or overloading. Isn't it? The current only not flows, no. For the short circuit and overloading, current must flow. But it has to be in high way, high level. Okay. But what happens when the fuse melts itself? It should have what are the characteristics of fuse? I will tell you. It should have low melting point. Okay. When there is more current comes, it should melt. Okay. When it melts means there is no path for the electric current to flow through the circuit. See, remember, when the electric current will not flow in the circuit, then there is no short circuit or then there is no overloading. So hence fuse is the material that prevents the circuit from short circuit and overloading. Okay, this thing you should remember. I hope you all are clear with fuse. Okay, fuse is always connected usually in series with the resistors. It is always connected in series with the resistors. Why? Because if it is connected in parallel, then current will flow again. If it is connected in parallel, it might prevent the flow of current through R1. But R2, R3, the current will split and flow. Isn't it? But if it is connected in series means what? When it melts, the current will not at all flow through R1, R2 and R3. See here, they are all in series. It melts here, then there is no path for the flow of current. When there is no path for the flow of current means current will not at all flow in the circuit. When there is no flow in the circuit means there will not be any short circuit or there will not be any overloading. Okay, this is the thing. So what is important in fuse? Which material is used? Sorry, not which material is used. The important thing in fuse is definition of fuse you have to remember, and melting point of fuse must be low and fuse must be connected in series with the circuit. These two questions may ask, or it might come in the multiple choice question. Fuse must be connected in dash with the circuit, in series with the circuit, in parallel with the circuit, or across the circuit, or you can say none of these. So you should remember fuse is always connected in series with the resistors or circuit. Okay, and fuse should have option A high melting point, option B low melting point, option C high boiling point, option D none of these. Fuse should always have low melting point. So when it is having low melting point means when the current is increased a little bit, that means before to short circuit, it is going near to short circuit. That time fuse melts itself and breaks the circuit, then there will not be any flow of current in the circuit. So this is the thing you have to remember. This is regarding what? Fuse. So bulb, which material is made up of? Or which filament is used in the bulb? Tungsten filament. Why filament is made up of tungsten? Because tungsten is having high melting point up to 3380 degrees Celsius. Okay, they should. And which are the gases filled in the bulb? Nitrogen and argon. Mainly argon. Why it is filled? Because if it is kept open, tungsten will react with oxygen and it will become tungsten oxide. Hence there is no working of bulb further. But if argon is filled, argon is a noble gas. It will not at all react with tungsten material and bulb works properly. So this way you can say. Understood? I hope you all are clear with these two concepts. Okay. Next we will move to last concept of this chapter. We will move to the last concept of this chapter. That is, what is the last concept? Power. That is electric power. This is not tough one. This is very easy. Electric power. We can say rate of doing work. P. What is electric power? The electric power is nothing but the rate of doing work. The rate of doing work is called electric power. Is called electric power. The rate of doing work is called electric power. So P is equal to W E by T. E is what? Electrical energy. So the rate of doing work, or you can say W by T. This is rate of doing work. Work here is electrical energy. Here work means electrical energy. Whatever the work they are doing, that is itself is electrical energy in this case. In the total electricity chapter, work and electrical energy both are same here. Whatever the work they are doing, that all is converted into electrical energy. So the work done per unit time is also called as power. But if you say the rate of doing work is called electric power. Okay, it is denoted by P. The rate of doing work is called electric power, or the rate of flow of electrical energy is also called as electrical power. It is very easy. The rate of doing work, that is power. So P equal to E by T or W by T is the formula. So if you take P, you can have another formula that we call it as VI. For E, what we can write it as? E, I can write it as VQ. In the last we have said electrical energy is nothing but voltage into charge divided by time. So Q by T is I can write it as P into VQ by T. So this is I. P equal to VI. So P equal to VI is the formula. You got this point? So this is also formula you should remember. P equal to VI. So you can define power by this one also. What is power? The product of voltage and current in an electrical circuit is also called as power. We can define in that way also. Okay, remember P equal to VI. So here we can get some formulas. What are those formulas? P equal to VI is there. In place of P, I can put what? Ohm's law. IR I can put IR into I. I into I square R. So P is equal to I square R. So P equal to VI in the same way I can put, in place of I can put I equal to V by R from Ohm's law. V equal to IR, I is equal to V by R. So V into I equal to V by R. So V into V, P is equal to V square by R. So these are the three formulas you have to remember. So what is the SI unit of power? The SI unit of power is watt, represented by W. The SI unit of power is watt, represented by W. Okay, but what happens? Electrical energy, this electrical energy is measured in joules and power is measured in watt. But sometimes what happens in our daily life, the joule is a very less unit. Okay, so sometimes for commercial use we will not use joules. We will use another one that we call it as kilowatt hour. instead of using joules, we use kilowatt hour for the measurement of electrical energy. So we will see that. So before that, I hope these all are clear with this power. The rate of doing work is called electric power. So that is, if you write on the definition base, P equal to E by T. Okay, E is equal to VQ. So I can put here VQ by T. Q by T is nothing but I. So P equal to VI. I got one formula. In place of V, I can put IR by Ohm's law. So IR into I square R. In place of I can put V by R. So V into V by R, V square by R. So what is the SI unit of power? Watt. So these things you have to remember. Power is represented by P. These are the things you have to remember regarding power. And the last concept is, so there are three formulas of power. Similarly, the three formulas for heat energy. So all those formulas how to use, we will see in our problem section or numerical section. Okay. Now we will see. What we will see? So there will be one question will be asked. What is the commercial unit of electrical energy? The commercial unit of electrical energy is kilowatt hour. So joule is the smallest unit. So instead of using that unit, we use kilowatt hour for the commercial purpose. So how much is equal to 1 kilowatt hour? See, 1 kilowatt hour. Prove 1 kilowatt hour equal to 3.6 into 10 to the power 6 joules. This might be asked. Prove 1 kWh equal to 3.6 into 10 to the power 6 joules. This might be asked for 2 marks. This is very much important. You remember this. 1 kWh. So I will convert this all into SI units. Convert. 1 kilo means how much? 1000. 1000 watts. Hour means how many seconds? So 1 kilowatt. Kilowatt should be converted to watt, because watt is my SI unit of power, not kilowatt. Hour. Hour is not SI unit of time. Hour means they are measuring time. It is not SI unit of time. What is SI unit of time? Seconds. So let me convert this into seconds. 1 hour is equal to how many seconds? 60 into 60, isn't it? In 1 hour there are 60 minutes. In 1 hour there are 60 minutes. In 1 minute there are 60 seconds. So 60 into 60. So let me write this one. 1000 into 3600. Okay. What is remaining here? 36. Now there are how many zeros? 5 zeros. 10 to the power 5. Okay. So I can write it as, by putting the point here. The point is here. I can bring this one here. Okay. Or you can say, you write by multiplying this. 36, 2 zeros and 3 zeros. 5 zeros. Where is the point? If there is no point, means you have to consider the last. So I will bring this side. 1, 2, 3, 4, 5, 6. So always it is preferably preferred that we should put a point after a first important number. Okay? After a first principal number we can say. So that is 3.6 into. How many times I have shifted left? 1, 2, 3, 4, 5, 6. 3.6 into 10 to the power 6 joules. This you should remember. 3.6 into 10 to the power 6 joules. You should remember this. 1 kilowatt hour equal to 3.6 into 10 to the power 6 joules. Kilo means 1000. Kilowatt means 1000. Hour means 60 to 60 seconds. So 1000 into 3600. So if you multiply this, you will get this much. That is almost 36 lakh. But you have to take point back so that we can express it in joules. 3.6 into 10 to the power 6 joules. This is the way you have to prove the 1 kilowatt hour equal to 3.6 into 10 to the power 6 joules. And remember this value. We can use this value in our problem section. I hope you understand. And define 1 watt might be asked. 1 watt. Define 1 watt of power. P is equal to VI. This is 1 when both they are 1. 1 watt power, or the power is said to be 1 watt. Power is said to be 1 watt if 1 ampere of current flows in a circuit, flows in a circuit which is having 1 voltage potential difference, which is having 1 volt potential difference or 1 volt voltage. Please refer the book for definitions also. Be perfect with the definitions. Read the definitions properly so you can know. See, both are 1, so you can say 1 watt. So power is said to be 1 watt if 1 ampere of current, this should be 1, this should be 1. 1 ampere of current flows in a circuit which is having the 1 volt potential difference, or which is having a potential difference of 1 volt. So this way you have to remember. Both are 1 means power is also 1, that is watt. Commercial unit of electrical energy, kilowatt hour. Don't forget. So 1 kilowatt equal to 3.6 into 10 to the power 6 joules. How it has come? We have remembered all. 1000 into 60 into 60, 1000 into 3600. So 3 lakh 36 lakh it becomes. Take the point from last two after first important number. So it will become 3.6 into 10 to the power 6 joules. So power is said to be 1 watt if there is 1 volt potential difference and 1 ampere current flows through the circuit. You can say in this way also. Or if 1 ampere of current flows through a circuit of potential difference 1 volt. Okay, circuit of potential difference 1 volt or circuit which is having 1 volt potential difference. Both are same only. So I hope everything is fine, everything is proper with this chapter. Okay, so theory part of this chapter ends. So you have to start solving your exercise. Okay, don't wait for the problems to complete, start solving your exercise. So wherever the problems are there, you will leave those problems, write those problems and leave some space for those problems. So when I solve those problems, you can write it down there. Okay, hope everything is clear with this. So this ends your electricity. So next class we see what? Next class we will see the problems and some questions of NCERT also we can see. Okay, so you start solving your exercise. If you have any doubts, please feel free to ask. My mobile number is already given. You can call or you can message in WhatsApp. Okay, or you can call or you can clear the problem, your doubts in your at least in doubt sessions. Okay, I hope everything is clear. So this ends your electricity chapter. So problems are there. Problems will be seen from next class. Thank you.